Welcome back to the second video in polar coordinates, and this is about sketching the polar curves and checking the graphical calculator. Guys, this is really important to understand this, and we see how does it work. Okay, so let me just see the steps I've written for you are these. It says draw a table of values for theta and find the corresponding values of r. Right, so this is basic to draw any graph. We did that in day 7 if you started drawing the graphs table of values. But very important, I would say, that you use those values of theta for which you get r as a positive answer, because Edexcel only wants you to plot the values of r where they're positive. For MEI, we do negatives as well, and I'll show you a couple of examples for both. And if possible, exact value. Right, so what do? As we take a standard values first, and then if we need a bit more, we can come into intermediate values after that. Okay, learn some standard shapes and equations by memorizing it. It will help. For example, this is r equals a, is a circle, center, r equals a. That means the distance from the pole is always constant, it's a circle. Okay, r equals alpha, theta equals alpha. That means the angle from the initial line is always same. What does that mean? It's going to be a line. Okay, r equals a theta. When you have theta multiplied by a number, it will be a spiral starting from a very interesting. We'll do a couple of examples for this as well. R equals a sine n theta, or r equals a cos n theta. We'll have n loops symmetrically arranged around O. For Edexcel. For MEI, the number of loops might change because we plot the positive negative values of ours as well. R equals a plus a bracket p plus q cos theta is an egg or dimple shape depending on the values of p and q. So very important. If we get an equation like this in sine as well in there, guys, we'll try and see if there's a dimple or not. Okay, right? And these are the examples. I've taken this from the textbook. These are the conditions. If p is greater than or equal to 2q, you get an egg shape, no dimple. If p is less than 2q or greater than or equal to q, you get a dimple there. Right, guys, these are something which you can memorize. Now we do the examples in a bit now. Okay, then we take from there. All right, like I said, we're going to be doing questions now, guys. This is my first question. R equals 3 cosec theta. Right, so I will be tempted to draw the table of values. Okay, before that, let me see, is this simple? Let me try. Cosec theta is 1 over sine, right? So I write down r equals 3 times 1 over sine means 3 over sine theta. Then I take r sine theta to the other side. That gives me r sine theta is equal to 3. And that, ladies and gentlemen, will tell you this is r sine theta is equivalent to y. So y is equal to 3. So I do not need to do anything. I can just do the sketching of this. Y equals 3 is a straight line. It should come out as straight line. So guys, y equals to 3 is a straight line. We plot a straight line there. On my x and y plane, this will be y equals 3. So that is my curve sketch for this polar curve. Okay, this is equivalent to y equals 3. I mean, this is one way, people. If you can easily change a polar equation into Cartesian, and it's easy to draw the graph that way, that's better. Sometimes it's not. So let's see if I have written down another question. Let's see if we can go on to that. Right, guys, so this is a really good question, exercise 5b, question 1I. Okay, those who have this graphical calculator, I would advise you that you check how would this curve look like on this graphical calculator first. Okay, obviously those who do not have it, we're going to try and work this for them as well. Okay, so let's see. Let me get the camera focused back for a second. There we are. So we got the focus back, guys. Now, very, very important. I would like to draw a table of values. Okay. And theta and r. And guys, idea is to go between 0 and 2 pi. Sometimes you can go between 0 and pi, and you can use symmetry to draw the other part of the curve. But I would advise you to go all of them. Okay, so 0 and 2 pi. So let's say we go on to 0 degrees, 30 degrees, 90. The reason I'm writing this on the top, because I would like to see this has to be in radians. Okay, let's write all of them. Let's use a calculator to work out the values. I want to take a pause here, and you can do it yourself, please. Thank you. Right, so this is 0, that's pi over 3, 60, sorry, after that will be 2 pi over 3, then it's 90, which is pi over 6. Look at the way I'm writing. So 2 pi over 6. That should be 3 pi over 6, which is pi over 2, and so on, guys. So before I make more mistakes in there, let's just write down, fill up the table of values. Thank you. All right, guys. So let's pick up the values. So when theta is 0, cos 0 is 1. So this is r is equal to a. When theta equals 30, 3 times 30 is 90. Cos 90 would be 0. That is 0 there. When theta equals 60, 3 times 60 is 180. Cos of 180 is minus a. So this is minus 1. So the answer is minus a. Okay. When theta equals 90, 90 times 3 is 270. So which is 2 cos 270 is 0. So that's 0. Okay. So guys, let's not make the video longer. Can you please fill up the values? Okay. Right, so these are the values I've got. So I'm going to start from the beginning and show, let's see, how do we draw this? So I will draw and grid. I will draw 30 degrees roughly here, and we'll come back as well because this will be 210 degrees. 60 degrees roughly here, because I've now gone in 30, so that's this, guys. This is 120. Then that will be 150. Okay, guys, let's try and make this graph now carefully. When theta is 0, that's on this line, r equals a. Let's say this is a. When theta is 30 degrees, r equals 0. So it's going to go from, as theta goes from there to there, this goes from here to here. So guys, I'm looking at something like this. Okay, I've done these two. As theta equals 60 degrees, okay, pi over 3, 2 pi over 6, 60 degrees, this one, it's negative. So I'm going to stop. I'm not going to plot that for the time being, okay, because Edexcel doesn't expect me to do that. As theta equals pi by 2, it's 0. So pi by 2 is 0. As theta equals 120, it's a. So 120 is that. It's going to a. So from 0, in this angle, it's going to go up to a. Let's say this is up to a. So it's going to go up to here. Okay, that's a, for argument's sake, right? And as theta equals v 120, 150 is this one, it comes down to 0. So from here, it comes down to 0. So I can see a clear petal there, right? Right. So now as theta is 180, it's minus a. I'm going to stop that for a minute. It's 210, theta equals 0. 210 is this line, it's 0. And 240, which is that line, it goes to a. So from here to here, let's say this is a. It goes from 0, it goes up to a. Okay. And then if it's 270, it comes down to 0 as well. That's 270. So that's your thing there. And then it is 300, it's negative. I'm going to avoid that for a minute. 330 is 0. 330 is this one, it's 0. And 360 is a. So it's going up. R is increasing from here from 0 to a. So guys, this is the graph. This is the polar curve. If you do not plot the negative values of this. Okay, so this is the graph. Have a look, try and understand what we need to do in there. Okay, so I'm going to show you how to work this in graph. So you press menu, you go onto this graph menu, press execute. Then it says type. Do you want R equals something? That's polar curve. So I'll select that type and I'll select R equals. And my equation is A cos 3 theta. But obviously, I cannot type in A there. So I'll just type in any number. Let me type 5 cos 3 and theta is that one. 5 cos 3 theta. Execute. You're going to execute it twice. That's the graph. And this graph does match with what our shape is. All right, guys, that's how we check it out. We do one or two more examples of this now. Okay, second question I would decided to do is at question 1J on the same exercise. Okay, so R equals 2 plus A times 2 plus cos theta. What I've done is I've compared this with the basic normal general curve, and I've written down P equals 2, Q equals 1. So P is equal to K, and the condition was if P is greater than or equal to 2K, 2Q, then there's no dimple, it will be an X-shaped curve. So I'm expecting there won't be any dimple in there. But I guess what I'm going to do is I'm going to do the same thing again. Let me see if I can make the table of values. I'm going to leave that to you. You do that for me as well. Go in pi by 30 degrees as well as we did last time. And if there's any more values needed in intermediate, we can check that later. So I'm going to stop, pause the video, and I'm going to make the values and you do the values yourself as well, please. I'm sure you're working out. So I've written down the table of values then. I will write down the values of R. So R is equal to 2 plus cos theta. So I know the values of cos theta for these angles. I'll put them in and work out the relevant value for R. Okay, so let's compare the answer. Okay, I'm sure you've seen this, guys. So I have left these particular values blank in here because if you remember in PowerPoint, I did say that we need the values which are exact if possible and positive. So in this case, I don't think we get any of the values as negative, but these were not exact, so I'll avoid that. Let's not draw this, okay? So guys, same thing now. I will be drawing that grid and I'll be drawing the lines with 30 degrees and extend it backwards for 210 and so on. So can you do that? Then we plot the values, see how does the graph look like. All right, guys, let's do that. Okay, so when theta is 0, it's 3a. I'll just try to label it a little bit to just see how far. When theta is 30, we don't know the value. When theta is 60, it is 2.5, which is if 3a was here, it'd be slightly lower than that, okay? So it will be slightly lower, right? So I'm going to see the curve is coming something like this, okay? Then if theta is 90, it is 2a, so it's coming here, right? So that point somewhere here, right? Smooth curve from there, okay? And then if his theta is 120, is 1.5a, so 1.5a will be roughly somewhere here. Okay, it's coming in, right? 5 pi over 6, which is not, I can't see, this is a, because it's coming down even smaller then, okay? There you go, so that is the curve I'm looking at, 0 to 180. Most likely it's symmetrical, so let's check. If theta is 210, we don't, it's not exact, so when it's 240, it is 1.5a. 1.5a will be somewhere here. Okay, and then 3 pi over 2 is 2a, so it's going up there, a little more bigger. And then it is 2.5a for 300, so 300 is there, it's 2.5a, 2a will be here, so I'll go slightly bigger. Okay, and then it is 3a when it goes there, guys. So this is an egg-shaped curve, like expected, no dimple. It's an egg-shaped curve there. Okay, you can verify this with your graphical calculator as well. Let's see if that works. There you go, and that's a graph. You can always see it's a little egg-shaped curve. It's no dimple there, right? So you can always check that with your graphical calculator. Next question from the same exercise is question 1M. It is sine instead of cos. So I've used the same logic and I see that there will not be any dimple. Let's see. I didn't write the pi's there, guys. You can obviously finish it off yourself. Just fill up the values. Okay. And we do write the values which are exact and which are positive. Okay. Let's see. What do we get, guys? Fill up the values for me. All right, guys, so these are the values I've got. The values which I've crossed out, they are not the exact, so I'll try to avoid them. Okay, guys, if theta is 0, it's 2a. That's a, that's 2a, okay. Right, that's a point. If theta is 30, it is 2.5a. It will be probably straight, you know, slightly going slightly like this, okay, straight up, not coming in as a circle. It's 2.5a. If theta is 90, it's 3a, so that's going bigger. Okay, so it's the graph is going something like this. That's 3a, right? So 120, we not exact. So 3a would be here, 2.5a will come in slightly, right? It will be coming in a little bit, similar to what it was there. Then 150 is 2.5, 180 is 2a, so it's coming in like it was there. Right, it's coming in there, guys, right? And then when it is 210, it's 1.5a, so it's coming down a little less than again, right? And then it's a, and then it is 1.5a there. It goes like this. So guys, it's, once again, it's an egg-shaped curve, okay? Obviously, it will be more symmetrical, and this portion is symmetrical to this one. So guys, this direct symmetry is this vertical over here. It's an egg-shaped curve. Okay, so we can check with the graph as well. Right, so we're going to be I'm doing a couple of shapes which have dimple now. Okay. All right, guys, let's check this one. I thought I'd look for something which has a dimple. This is exercise, same exercise 5b, question 1m. So P is equal to 4, Q is equal to 3. So P is this time less than 2 times 3. So P is less than 2Q. That means we're expecting a dimple in this graph. Okay, so guys, can do me a favor. Can you please put these values into this and work out the answer? And I will pause this until then. So save time so video doesn't get very long. That's theta, that's r. Let's figure out the values. Do that for me, please. Thank you. All right, guys, these are the values I got. Hopefully I've got them right, and we'll see if we're expecting a dimple. Let's see if we get a dimple. When x is 0, it's 7a. So that's 7a is the highest. Let's make it big here. 7a, let's see, it's here. X is 30. I don't think I get it exact. When x is 60, it is 5.5. So 7a would be somewhere here. I'm coming in somewhere. Okay, 5.5 and a half a. Right, so graph is something like this. Okay, then it is when it's 190, it's 4a. So that's 5.5. 4 will be coming in again. Okay, it's getting smaller and smaller. And then for 120 is 2.5a, it's even getting smaller, 2.5a. 150, I don't know. 180, it's a, so a will be smaller than that as well. Okay, a, that's 2a, this is a. And then from 180 to 210, I don't know, 240 is 2.5a, 240 is 2.5a. If that's a, that's 2.5a, okay. It will be roughly here. Right, then it is 270 is 4a, 4a is 2.5, so it gets bigger. So if that's 4 as well, 4a, I'll write down here, that's 7a, so it'll be 4a there as well. It's being symmetrical, that's 4a. And then it is 5.5a, so 5.5a is there, so it will be somewhere over there as well, guys, 5.5a. And then it's 7a, so guys, it's going to go all the way. Yes, because that is the curve, and we expected the dimple, we got a dimple at pi. Okay, so when theta equals pi, we got a dimple there, right? That's one of the questions. I'm going to do one more question now, guys, where you might need to work out an intermediate value. Okay, so the 30s, going up with 30 sometimes doesn't work, so we might have to work 45 as well. I'll do a question now. All right, I picked this question up from MAI book. This is 5.2 exercise and question number 3. Okay. So r equals 3 cos 2 theta. I mean, obviously, guys, you don't make a table with these values, right, in terms of pi, or write few anyway, because your calculator will do the answers, okay? I'm going to write down all the values for this when r equals 3 cos 2 theta, and then we see how to, and because it's MAI, I'm just trying to write down the negative values as well, if I can. Okay, see how it works. Right, so these are the values I've got. And I will be obviously drawing it for Excel purposes when we do not draw the negative r's. So when r is when theta is 0, r is 3. Let's say this is 3. When theta is 30, r is 3 over 2. So somewhere over here, it's coming in half. Okay. Then 60 is negative 3 over 3. I'm going to avoid drawing that. 90 is negative 3. 120 is negative. So 150, which is this one, is 3 over 2. So roughly at the same height. Let's do that. 3 over 2. Okay. And 150 is 3 over 2. And 180 is 3. So it's going up. So I know this is a part like this. Okay. Right. And then 210 is 3 over 2 again. So that's, I'm coming back 3 over 2 again. And 240 is negative, 270 is negative. So 330 is 3 over 2. 330 is this, so it's 3 over 2. I'll come over here, 3 over 2. And 360 is 3. So guys, I can get this half petals, but then I need to see, well, how does the curve behave between these and here if I just do the positive ones. So guys, let's try something in the middle. Let's see what's middle of 30 and 60 is 45. Let's try. So 45. When theta is 45, okay, so cos 2 times 45 is cos 90, cos 90 is 0, so r equals 0. That clarifies it, people. So on 45, it comes to 0. Okay, similarly, so we're going to see clearly this curve is going to be like this for here as well. It's going to come to 0 for 45. So this curve is going to be like this, guys. These are the two patterns for Excel purposes. If it was for MEI people, MEI plots -1 as well. I'm trying to see if I can get different color pen. If not, I'll just do this there, guys, anyway. So what happens when theta is 60, which is that line, sorry, the r is -3 over 2. So instead of going 3 over 2 here, I'll go in the opposite direction, 3 over 2. Okay, that's 3 over 2. And then when it's 90, it is 3. So I'm going to go a curve from 3 here, curve from here to there. Right, opposite. 90 should be there, but because it's negative, it's coming in this way. 120 should be on this line because it's negative, is -3 over 2. So that's where this curve comes there as well. And guys, you'll see there will be a curve like this. And similarly, plotting the other values, you'll see there'll be a curve like this as well. For MEI, you show this 4 petals. For Excel, just the blue ones, like I discussed before. Excel doesn't need you to plot the negative values of R. But what happens if you have 2 people? Negative values out, it flips like negative enlargement. It flips into the other quadrant on the other side. Right? So this was a question where we had to use intermediate values 45 to figure out the nature of the curve from here to there. Okay, look at that one more time video if you have to. Okay, right, it's part of the same question in MEI. Let's work out the values in there, guys, and then we plot the graph of our 3 cos 3 theta. So I'm going to pause it. You can do this values yourself. These are the values. I'm just trying to show it to you again one more time, guys. How do we draw this? So 30 is roughly here. We draw a line backwards there as well. 60 is roughly here. We draw a line backwards here as well. So 120 is roughly here. Draw a line backwards there as well. 150 is roughly here. Draw a line backwards there as well. Like obviously, it's not exactly 150, slightly bigger, but that's fine. Guys, when our theta equals 0, it's 3. Could be A as well if there was A, right? So 3. Right, theta equals 30 comes to 0. So I know it's going to come this way. Okay. When theta equals 60, it's -3. Let me avoid it if I can. Okay. So theta equals 90, it's 0. So 90 is 0 as well. 120, it's 3. So that's 3. 120, it's going up like this. Okay. 150 is that one, comes down to 0. I can get a full petal there. 180 is -3. I'm going to avoid it. 210 is 0. 210 is this one is 0. 240 is 3. So it's going to go, let's say there's 3. It's going to go up and 3. And 240 is 3. I've got that. 270 is 0. So it's going back to 0 there. Okay. And 300 is -3. I'm going to avoid that. So 330 is 0. And 360 is 3. So it's going to go there. Okay, that's the graph. Y equals 3 cos 3 theta and 3 petals there. All right. If for MEI as well, let's try the MEI purposes, guys. So with 60 is minus 3, 60 is minus 3. So that's already already there, 60 minus 3. Okay, 180 is minus 3. So 180 minus 3, I should go reverse. That's already there on 3. Lovely. So that means we still get only these 3 petals there. So guys, this is how we do the sketching of this curve. This is our video number 2. So we'll come back to next video to show how do we work out the area of the sectors. Thank you very much. See you soon.